Okay, hi everyone. I'm Kevin Bowman. I'm in charge of messaging for the dev test product. I'm going to show you some our virtualization support for RabbitMq. I'm going to start off with a little bit of review for anyone who's seen the first talk that I gave on the test step, and then we'll dive into VSE. So can everyone see my screen okay? Everyone can see the RabbitMq homepage?
We see it.
Great. Okay. So what is RabbitMq? It's an implementation of AMQP, which is a messaging protocol, advanced message queuing protocol. If you go to rabbitmq.com, they have some documentation. Go to docs, all the way down, protocol documentation, compatibility, and it lists exactly the versions of AMQP that it's compatible with. They also have a section on interoperability for, like, if you want to do AMQP with a different provider, like Apache Cupid or OpenAMQ. They're mostly compatible, but there are a couple of caveats. When you get down into the details that they mention are not quite compatible between the two. They implement the spec differently, that kind of thing. The basic takeaway is we can only guarantee that our RabbitMQ support is compatible with RabbitMQ. You may be able to use it to run against other AMQP providers, but you might fall into some of the caveats that they list on the site. So how do we get started? So the first thing you're going to want to do is get the RabbitMQ client jar. So that's under installation, official clients. Just download the Java client zip. I have that here. There's a bunch of files in here. The only two that you need are the commons.io.jar and the RabbitMQ client.jar. Just take those and you should be able to copy them right into your dev test home hot deploy. Some other things that you'll need to do, because this is still experimental, is you're going to need to create or edit your local properties and add in a line. We said that experimental equals true to enable the experimental assets and the test steps. And you also need to, there's a add-on file under the installation directory, add-ons, messaging, add-on rabbitmq.jar. That this enables the VSE transfer protocol. So you want to take this and also copy it into hot deploy. If you want to set up a full demo using the sample app that I'm going to be using today, you're going to need to install the RabbitMQ server, which is free. You can download it from their site. And you also need the client application that I'm using, and instructions for all that is available on our internal Confluence page for installing and running the RabbitMQ server and running the sample app. So once all that is set up, I'm going to create a new project here. And let's take a look at the assets. So there are a number of new assets here in the when you open the configuration. The first thing I'm going to do is I'm going to create a connection. It's the first thing you're going to need. I'm running RabbitMQ server locally, and I'm also already running. Actually, let me start my service here. So this is my normal messaging service where I just have a service that runs against that's on a request queue. And I have my client side that I can run against that, and you just send a simple query, and it'll send back a simple response. You can see the response on the service side here. So I'm going to set up the queues I need to use that to set up a recording of that service. So the first thing I need is a connection here. I know it's running on localhost. And by default, out of the box, RabbitMQ requires a username and password, and they're guessed, and the password is also guessed. Let me test that out. Great, that works. So now let me create a queue. And I already know the names of the queues here. I'm going to select the connection here. Test that out. Great, that works. And I'm going to duplicate that, and I'm going to make a proxy request queue. So at least on the request side is still, the recording is still works the same as other messaging recordings. You're going to need a live request queue and a proxy request queue. So I just created the live one. Now I'm going to create the proxy one. Get the channel set up, and I'm going to test it. So this queue actually doesn't exist yet. But the thing about RabbitMQ is it's very easy to create queues on the fly. For the most part, you don't create queues administratively like you do with MQ and most JMS providers. I'm going to enable the advanced features here and just click a checkbox to say I want to declare this queue, which will create it on the fly for me. So I'm going to run this again. And now it's successful. And I can leave this checked. It doesn't matter if you create the same queue over and over again. It only has an effect the first time you do it. And now one last thing I'm going to create here is a temp queue. So this is what I'm going to use for the response side. So just because of the way that RabbitMQ is built in AMQP in general, I'm betting that most of the time you're going to see people using temporary queues for the response side. So that's what I'm going to show today. So first of all, I just need a channel. Let me test that out. Works. Some other assets that are in here that you may or may not need to worry about. There's a channel asset that, for the most part, you should never have to deal with directly. It doesn't even have any real parameters in here besides a connection. So this is kind of an intermediate object that we use when we behind the scenes when we have to connect to RabbitMQ. And if you really know what you're doing and you want to control the scope of that particular of the channel as opposed to just the connection, then this is available to you. But 99% of the time, I'm guessing you'll never need to mess with this. And the last thing we have here is an exchange. Now, if you saw the talk that I did on the test step, I went into great detail on the exchanges. I'm going to kind of gloss over that for this one. If you want to know about the different types of exchanges, actually that's not, yeah, the different types of exchanges and what they all mean, and I go into that in the other talk. I won't go into that here, but since we won't for the most part, unless the customer is explicitly doing their own thing with exchanges, there's a lot of default behavior that we can fall back on. Like there are default exchanges created for all the different types. There's another default exchange that allows us to send directly to a queue. So there's a lot of default behavior built into our support that if the customer isn't really worrying about them, then you shouldn't really have to either. So now I've got everything I need set up. So let's actually run a recorder. So find the RabbitMQ transfer protocol. Create a service image and a model. Next. So if you're familiar with JMS and IBM MQ native, this should look very familiar. You have your request channel and your response channel and your proxy sides of each. So I'm going to set up my proxy request queue and proxy response queue. And on my proxy request queue, live request queue, and for my proxy response queue and live response queue, I'm going to choose the same temp queue. And this is kind of, it doesn't actually matter what you pick for the proxy response queue, because when temp queues are being used, the client side is going to send us a request message that has a reply to. It tells us where to respond, and that's going to override whatever you select in here. So it's just for consistency's sake, I like to pick the same temp queue on both sides. This does not create two temp queues or use the same temp queue twice or anything. It's just a placeholder here to make sure that I know that I'm using the reply to on the response side. Now this temp queue is created. It's when we forward the request, we'll create our own temp queue and overwrite the request reply to with that temp queue. So it's the same basic operation as all the other messaging providers with temp queues. Okay, that's set up. Let me go back to my services running, my client. I'm now going to essentially reconfigure my client to talk to that proxy request queue. So let's send looks like it's going through my recorder. I can see my message count increasing. Let's run a few more. And I can see all those transactions hitting here on the on the service side. I'm going to just breeze through the data protocol. It's still messaging, so you're still going to need a data protocol to be able to pull anything useful out of the payload. Otherwise, it's just an opaque string that we don't know what to do with. And it's a simple request response. I'm going to set up a simple data protocol here. Okay, that looks good. And I'm done. So let me open both the service image and the model. So the service image, the default value for the operation is going to be the name of the request channel. If you can have more than one request channel in there, I'll show that a little bit later. You can override this with the data protocol handler if you want. And on the response side, there's going to be some metadata. The only two that are important are the channel names. So this is the name of the response channel. So if I have more than one response channel, this is which one I use to send that response. And then any properties starting with MSG dot, those are ones that are used to create the actual response message. There might be a handful of these. There might only be one, but those and the channel name are the only ones here that matter. The rest of these things, the connection settings that I used, those are just there for informational purposes. All the actual connection settings is stored in the assets that are used from the service model. And you can see that the service model looks basically like other VSE protocols, and it's exactly like the JMS and IBM MQ native protocols. There's a listen step with the proxy side of the request channel. And there's a response step with the proxy side of the response channel. Again, this is from what I put there in the recorder. So this is using a temp queue that's going to be overridden by the request replied to. It doesn't really matter what's in here if reply to is being used. And then there's a live implication step that has the live sides of the request and response channels. So let's deploy this. Okay, I can see my service running now, virtual service. I'm going to go back to my client, which I have not reconfigured. It's still on the proxy request queue. I'm going to run another transaction through, and see it does not hit my live. It doesn't hit my live service, but it does go through my virtual service. And I can tell this for sure if I enter something that has to hit the meta. That isn't one of my original specific transactions. I get the meta transaction back. But if I change to pass-through mode, livification mode, I run that same one again, I can see the response is not different, and it did hit my live service. So what are some of the advanced features? So if we go back to that was kind of a basic run through. But what are some of the other stuff that we can do with this? So like I mentioned before, you can have multiple request channels. You can have multiple response channels. If you want. There are also some advanced features under the Pro button. And so far, this is all the same between all the messaging providers, JMS, IBM MQ Native, and RabbitMQ. You can generate, so by default, we'll generate the service so that it listens on the proxy queues and supports live implication. If you want the service to listen on the live queues and not support live implication, then you can just select that instead. There's some performance tweaks that you can mess with the number of recording threads. If you want to support multiple responses, then there are 2 fields to allow that. Basically, if I want to support up to 3 responses, and I know that each each request has at least 2 responses, and I can give the recorder kind of hints on how to behave. I can always just set this to 1 and this to, I think, -1 is an unlimited number of responses. But again, it's best to limit it if you can, because otherwise you might have a performance hit on the recorder waiting for responses. And you can also set a timeout, the maximum number of time it'll wait for a response. So all this stuff and you can also set the scope. So whether I should share connection assets. If you're familiar with any of the other talks I've given on the messaging steps, you should be familiar with what the scopes mean. Basically, it's how messaging assets, connection objects, and that kind of stuff are shared among different threads, or even all the way up to sharing assets among all RabbitMQ services on the same VM. So all that is the same between is just the same as it is with JMS or IBM native. The thing where it's a little bit different is with the correlation scheme. So RabbitMQ correlation doesn't really work like the other messaging providers. It has to do with the exchanges that I've kind of glossed over so far. So you don't send a message to a queue. You have to send a message to an exchange, and that exchange can use some routing rules inside of it to route to one or more queues. And our correlation schemes are built on the different exchanges. So there's one for each different type of exchange. There's direct, topic, and headers. And I kind of went over these in the test talk on what these different exchanges actually mean. The server side and in the recorder and the VSC service side correlation schemes, they all work exactly the same as those. The only thing that might be a little bit weird is there's a new property here called override. Basically, what happens is we're using the same exchange on both the proxy and live sides, which makes things a little bit complicated if we want the response to come back just through our recorder and we forward the response back to the client side. We actually have to change, if they send the message through with a particular correlation identifier, we actually have to override that identifier with something else so that it comes back to, the response comes back to our listener and not the live client's listener. It's really hard to explain. I'm sorry if I'm confusing everyone, but that's basically why this says yes. This defaults to yes instead of no. To make that is to make this kind of scenario where it's the same exchange being used both on the live and proxy sides just work without having to mess with too much. If you wanted to, you could leave the pro button off and you could just pick one of those exchange-based correlation schemes. And the last one here is the payload-based schemes, which again is similar to the ones for JMS and IBM native. If you have a response message where the correlation ID is embedded somewhere inside the message body itself, you can pull it out with a regular expression or with a XPath, and that'll make sure that we get the request and responses correlated together correctly once we're recording. That's all I had prepared. If you want, I could demo a different correlation scheme, but it's going to look exactly the same as the last demo did. So
Great. Thanks, Kevin.